Sue, while we're waiting, do you want to mention the events you have coming up on the 1st and the 3rd?
Yes, we are going to have on Wednesday, March 1st at 7 at night. This is the Climate Action Lincoln. We're having a workshop about climate planning. And then also on Friday, March 3rd, the workshop will be at 8:30 in the morning. And there's information all around about it's all virtual, so how to join. So the idea is to explain to people what the climate action planning is all about, and then also to hear what everybody's thinking, experiencing, answer questions and all that. So please come.
Thanks, Sue. Sorry for putting you on the spot, but I thought it was a good opportunity for a plug.
Thank you very much.
All right. Well, let's get going. People can join us. I'm giving the introduction. I want to thank everybody for attending this evening. I'm Colette Sizer, and I organize people in the CFREE working group. I won't say that I lead because they're a pretty dynamic group, but I just keep everybody organized. This is the first presentation in the Getting to Zero series presented by CFREE. And by the way, CFREE stands for Carbon-Free Residential, Everything Electric. We are a working group of the Lincoln Green Energy Committee. And I'm just going to take 2 minutes and tell you more about who we are and what we do. So we can make history right here at home by embracing climate change as a global challenge. Our objective with the Getting to Zero series is to motivate Lincolnites, us, to take steps to reduce our energy usage, to eliminate the use of fossil fuels, and by doing so, increase the comfort of our homes and hopefully reduce our cost of living. The first presentation in our series tonight talks about the envelope, what we can do with our floors, roof, windows to help reduce energy loss. Following sessions the session next week talks about windows specifically and is delivered by Patrick Muzilla. He is president of EAS in Acton, and he's very informative and can talk all sides of windows. And we have further presentations coming up, and in a minute I will put up our schedule. We just want to make sure that you know what all the rebates are and incentives that can reduce your cost of retrofitting your home. So we will include this information in every presentation. But why net zero? Why do we even care? Why should we even try? Well, how about this? Reducing your carbon footprint reduces greenhouse gas emissions, and that slows the rate of temperature rise, glacier melting, sea level rise, and ocean acidification, which reduces extreme weather events and improves air and water quality. And that maintains a healthier environment for us and other plants and animals, which maintains biodiversity and supports a healthy food supply. And all of this impacts our pocketbooks. Severe weather, medical expenses, high food prices, those are expensive, but innovations that provide solutions to protect our planet reduced our cost, and they provide new jobs. This is just a graph of Massachusetts energy consumption by end-use sector. And you might say, well, why are we talking to residents? Why not talk to commercial and industrial sectors? Why not focus on transportation? Well, we are focusing a bit on transportation, which is about 28% on this chart. But look at the number associated with residential, 32%. We can do better. So how can we do that? We can be aware, we can educate ourselves and our neighbors, we can go electric and reduce our fossil fuel usage, we can insulate and seal our homes, consider triple pane windows and solar panels, we can replace fossil fuel heating systems, and we can drive an electric car. We can live clean and green. We can recycle, compost, limit waste, and reduce air travel, and more. And that's where CFREE comes in. our Getting to Zero program schedule begins with the FLIR camera, and this will be posted where the FLIR camera helps you identify where your energy losses are. And we'll have a presentation posted on our website on how to use one. Tonight, we're talking about the envelope. Next week, we're talking about windows. In March, we're going to present solar. We have a session on retrofit of the historical home, adding heat pumps, living clean and green, and hopefully one on recycling in May. And although it's not part of this series, we don't want you to miss our electric vehicle show on July 4th. So with that, I want to introduce you to Rachel White. Rachel is CEO of Byggmeister, and she hired Byggmeister to come in and renovate her house in 2009. And what began as an effort to improve the functionality of her home and reduce her carbon footprint ended up becoming her life's work. She was initially employed as a consultant and helped develop standards and goals for energy and water use and indoor quality, and to track these over time. Rachel's role as a full-time employee eventually led to marketing, project management, and eventually in 2018, CEO. So Rachel, I think you fell in love with this. Rachel frequently speaks to community groups like ours and speaks to industry on energy and efficiency and low carbon operations. She's active in a wide variety of professional associations, including the Northeast Sustainable Energy Association, NSCA, where she recently stepped down or finished her term as board chair. So Rachel, we are really excited to hear from you tonight, and please take the floor.
Really wonderful for me to be here with all of you tonight. Thank you so much for inviting me. Interview, right? You're seeing the audience view?
Yes.
Thank you. So let me, Colette gave me such a nice introduction. Let me tell you a little bit about Byggmeister Design Build, which is the firm that I work for. We are a 40-year-old residential design build remodeling firm. Design build means that we do all of the planning as well as the production for our projects in-house. And I should say remodeling and retrofit firms means that we do a combination of sort of standard renovation work, kitchens, baths, finishing out basements with home performance upgrades. And in fact, our sweet spot is combining those two types of projects together, where we're improving the efficiency and comfort, reducing emissions of a home at the same time as we're also making it more livable and more functional. So I am really excited to be presenting at the first of what looks to be a fantastic series on, and I've titled my presentation, Getting Your Home Closer to Zero. I put it in parentheses because one of the things I'll be coming back to again and again throughout this presentation, just to foreshadow, is that with existing homes, it's really important to do what we can and to not get discouraged. And also be realistically optimistic, I guess, or optimistically realistic about what we can accomplish with our existing homes. There is a lot that we can do, but we're getting our new homes to the same performance standards as the best in class new construction is really, really difficult. So it takes time, it takes patience, and it's something that can be implemented over a series of projects over many years when the time is right, sort of opportunistically, as you need to undertake upgrades such as replacing your heating and cooling system or replacing your siding or replacing your windows. So it doesn't need to be done all at once. It can be done over time as you get closer and closer to that end goal. Start my presentation with sort of this roadmap of 3 steps to decarbonizing your home, which in a way I think could be a roadmap for this series because it seems to go well, not entirely in the order of the series, but there's sort of 3 steps that we need to think about, or it's sort of, I think of it as like a 3-legged stool that applies both to decarbonizing our home, but also more broadly as we think across sectors of the steps that we need to take in order to achieve our societal climate emissions reduction goals. The first is we need to improve the efficiency of how we use energy. And for our homes, that means improving the efficiency of the building envelope with air sealing and insulation. I'm not going to talk much about windows tonight because I know you're going to have a session focused on that next week, but windows and doors obviously an important part of the building envelope as well. That's the first step. The next 2 steps, which don't necessarily need to be done in that order, we like to say efficiency first, but then the next 2 steps, electrification and relying on renewable energy, a lot of those often go hand in hand. If you're thinking about switching over your heating and cooling to heat pumps, you may think about how if you're also installing solar, how you're sizing that solar so that it will meet more of your loads. But in any event, after you've improved the building envelope as much as you can, then you think about, or as much as you reasonably can, then you think about going all electric, as CFREE is name is, switching all of your end uses to electricity. And of course, you don't need to invest in solar in order to switch to renewable energy. You can enroll in Lincoln Green Energy Choice, as many communities have, and opt up to 100% renewables. And you can do that right now. Although I bet everybody on the call everybody on the Zoom tonight has probably already done that. So why do we start with building efficiency? Why does Byggmeister start here? Why is this the first session in the series? A few reasons I'd like to call out tonight. So I'm actually going to talk about these in slightly different order. So really, I have them here. So one is that by starting with building efficiency, you have a chance to drive down your building loads so that if and when it is time to upgrade your mechanical equipment, that you're able to install lower capacity, hopefully less expensive equipment. In other words, so that you think about, if you think about switching over to electric before you have reduced your building loads as much as you can, you'll end up you'll need higher capacity equipment. It will likely be more expensive. So that's really why in the order of operations, we say start with efficiency first. That's one reason anyway. Another reason is you're going to be more comfortable. You're going to have fewer drafts, fewer cold spots, sort of disparate temperature in different areas of the house. The environment will be more thermally even. And so therefore you'll be more comfortable. Of course, the biggest reason we're all here tonight, I think as Colette started, is that by driving down your building loads, focusing on the efficiency of the envelope, you'll also achieve greater reductions in your energy use and your carbon emissions than if you hadn't focused on that. And finally, if we zoom out and think about sort of the bigger picture in the systems, and I don't know how much you've talked about this in any of your other programs, but we need to think as we electrify our end uses of energy, we also at the same time need to be making dramatic upgrades to the electric in order to accommodate those additional loads, particularly during peak events. And so the more that each of us can do by using energy more efficiently, the role in creating, I guess, or decreasing the strain that we would put on the grid during peak events. And that's a much more complicated issue than I know we're going to get into tonight. But that is another reason why efficiency is first, is to drive down loads so that the grid is not having to do more than it otherwise would need to do in order to help us meet our goals more broadly. Okay, so I've broken up, again, I am not focusing too much on windows tonight because you're going to have a whole session on that. So I've broken up my sort of envelope recommendations into some that are specifically about air sealing and some that are specifically or more about insulation. Obviously, those two really can't be separated entirely. They definitely intersect and overlap. But I'll start with air sealing. And this is a graphic that many of you may have seen before that shows, you know, if you sit at the top left of the graphic, sort of common air leaks. The blue arrows are showing places where commonly you have cold air leaking into your house, and the red arrows show places where you commonly have warm air leaking out. A lot of the cold air infiltration happens down low, and the exfiltration or the exiting of the warmer air happens up high. We know sort of warm air rises, and you get these convective air currents with cold air coming in the bottom, getting heated up and rising, and then exiting the building. So these leaks happen at sort of common penetration points. They happen at intersections between roof planes, and anytime you have a plane change between a roof and a wall, those are places where you can have air leaks. And our approach at Byggmeister is to address sort of the biggest holes that are the easiest to get to, the ones that you don't necessarily need to do a lot of demolition and putting things back together in order to address. Oftentimes those are accessible at the basement level, where a lot of those blue arrows are showing down low, or sort of accessible in unfinished basements, similarly in the attic. And so, and again, that gets to the second point, sort of focusing on the top and the bottom, that those, in terms of the reducing that that circulation of air through the house, driving that convective heat loss, to really address the top and the bottom first. That doesn't mean that the leaks in the middle don't matter, but sort of the weakest spots or the biggest holes that are going to be at the top and the bottom. My list. You talked about having the flare camera. I don't know. Is that something you're making available for people to borrow, or is that's so cool? Help you identify places where you're missing insulation. The tool that we use, which is not really a household tool, that we use to help us identify air leaks, and we sometimes use it in conjunction with an infrared camera, is the blower door. And the blower door we use to measure overall air leakage rates of buildings. We also use it for quality control. So many air leaks aren't visible, but some of them are easier to detect when typically we depressurize the house, and the standard is you depressurize it to 50 pascals. And then that's sort of the equivalent to, I believe it's a 20-mile-an-hour wind blowing at the house. That really helps you to better identify the leaks. So when we're doing our renovation and retrofit work, during the course of the project where we'll use the blower door, again, for quality control, in order to make sure that we have the leaks, and to try to catch any that aren't easily detectable to the naked eye. And then coming back to my the title of the presentation, Getting Your Home Closer to Zeros, I would encourage you to be realistic about what level of airtightness is reasonable to achieve for most existing homes. So many of you may be familiar with the standard, the Passive House standard, which is sort of like best in class standard for high performance new construction. They set a floor, or I guess it's not a floor, it's a ceiling of 0.6 air changes per hour at a Pascal differential of 50. So that is a very, very tight building envelope. Is that we can get those air changes per hour down rarely below 3 air changes per hour for an existing home if we're not doing a super insulated retrofit. Doesn't mean that it's not worth doing. Obviously, it's very much worth doing, but it is really hard to get existing homes to the standard of new construction, and that's okay. There are lots of reasons to work on fixing our existing homes. We're certainly not going to replace them all with new homes, so we need to do what we can where we can. And it's okay. We don't need to make all of our existing homes equivalent to a passive house. To insulation. With addressing reasonably accessible weak spots. So what do I mean by those? So attics, open attics are often a good place to focus, or a place you would want to put on the high on your priority list. We're in many attics on a regular basis where the insulation looks like the insulation in the upper photo here, sort of clumped together. Some places, you know, in general, it's not thick enough, but it often gets moved around as work is done over the years, as plumbing vents are run, or as HVAC equipment is put in, or lights are put in, and it ends up and it was originally installed. And so that, especially in attics that aren't used for storage, as this one actually is, or attics that don't have mechanical equipment in it, that is a sort of no-brainer improvement, I would say, and many of you are probably also aware of that. I don't have a picture of it here, but also if you have uninsulated walls, particularly of you can clapboard siding or shingles, that you can take those off. The Mass Save can insulate those well from the outside. So that's another, I would say, top priority insulation. If you have uninsulated walls, if your walls are already insulated, even if they're only mediocre insulation, so you may see when you use the FLIR camera, you may see sort of spots. Walls are insulated, but oh, maybe there's a spot below the window or above the window, or there's a spot where the fiberglass has gotten squished or cellulose has settled. It can be hard to do more for those walls. But if your walls are uninsulated, any walls are uninsulated, it's a real no-brainer. All known as the rim joist or the band joist, that's where the wood framing of your house sits on the foundation. I've tried to sort of on the stone foundation, I've tried to sort of capture a photo of that here as well. That's again where the wood frame begins. That sort of perimeter that goes around the building is known as the rim joist or the band joist, and that's an area that if it hasn't been, you may have been in houses, or maybe at your own house, Mass Save will come in and they'll air seal and insulate all the way around the perimeter, which is through. So I've tried the examples I've just given are those are all three examples of things that Mass Save incentivizes, that Mass Save incentives will cover doing. You may find at your, if you haven't done those things, I would definitely recommend doing them and taking full advantage of the Mass Save weatherization incentives to do so. But you may find, we often find this to be the case, that where it may make sense to do more than what Mass Save covers. Mass Save, for example, will not cover the cost or incentivize the work to insulate basement walls. So they will only incentivize and cover the very top of the wall, that band joist area. So that's just something to be aware of, that just because Mass Save doesn't mean that it's not worth doing. There may be things for your house that make sense to do that go beyond what Mass Save will cover, but it's to start with what Mass Save will cover. Is insulation at the roof plane of a house. So this is the type of thing that you would want to do, particularly if you have HVAC equipment in your attic. You have an air handler and ductwork that's either cooling or cooling and heating. Often find this in attics for the second floor of a house. If we are where the insulation, the thermal boundary is at the attic floor, and then the HVAC is above that. It's essentially thermally outside. I mean, it's not outside in the rain and the snow, but the thermal attic with the equipment. Yeah.
Could you check your audio? It cuts out every few, I'm not sure your connection's tight.
Sorry, I wish you had told me earlier. Let me take my
It's just a
headphones
little
off.
bit.
One second. I'm going to stop sharing and I'm going to change my audio input. Okay, how's that?
That sounds great.
Oh, but now I can't hear you. Can you say something, Belinda?
You
Okay.
sound great right now. Okay.
Okay. Sorry, that was okay. I'm going to start sharing again. I wish you had cut me off earlier. I'm so sorry.
It was just getting slightly worse each time, new slide. So I was like, okay, now it's time to change this.
Okay.
We only missed a little bit.
All right. I'm going to share my screen again. And I'm so sorry about that. Okay, I think you guys are looking at the right screen. Okay. All right. So I think what I'll just start back at the beginning of this slide. What I was saying in the previous slide was that there's a lot that Mass Save covers: attic floor insulation, attic wall, wall insulation, as well as insulating around the band joist in the basement. And if those are things you haven't done, it's really important to start with those things. But there may be work at your house that makes sense to consider doing that might go beyond what Mass Save covers. And an example of that is moving the thermal boundary from the attic floor to the roof. And the time when you might want to do that, or when we would recommend that one would do that, is in particular if they have you have HVAC equipment, heating and cooling equipment, and ductwork in your attic. And in that case, you want to make sure that that equipment is thermally indoors, so that it's operating at roughly the same thermal conditions as the house that you're trying to heat or to cool. And so this image here shows an example of a project that we did where, as part of the project, we were installing a ducted heat pump in the attic to serve the second floor bedrooms. And prior to the project, the thermal boundary had been located at the attic floor, but we moved the thermal boundary and insulated the underside of the roof in order to bring that HVAC equipment indoors. So that's an example of where Byggmeister would recommend going beyond what would be covered through Mass Save incentives. And our typical practice is to focus on doing the best that we can within the existing framing of the building. So insulating in the wall cavities, insulating the underside of the roof. We would, in this case for this project and in many projects, we would build down the roof rafters slightly in order to install a thicker layer, higher R value, higher insulating value insulation. But it's rare for us to add insulation to the outside of a building, to take off the roof and take off the siding and outsulate or add exterior insulation. We do that very occasionally, and it's certainly something that to consider if you are also engaged in a re-siding or re-roofing project. However, we often work in homes where the roof is fairly new, for example, and doesn't need to be replaced. And so we typically, more often than not, find ourselves focusing on doing the best we can within the shell rather than thickening the shell. And that's really the sort of drive home that point again about what we have found is that in order to get to sort of the best in class new construction for existing homes, we would need to super insulate them. We would need to add insulation, what I typically call outsolation, which is insulation outside of the existing shell, outside of the wall sheathing, outside of the roof sheathing, and then to re-roof and re-side and obviously redo the exterior trim. We occasionally encounter houses where that makes sense because of the life cycle
of the siding and the roofing. But we don't get discouraged when that's not the case, or try to advocate that people take off the roof if the roof is only 5 or 10 years old, for example. And that's okay. We think it's okay. All right. So this was, well, you talked about IRA incentives. So I was looking at your write-up for the program, and then I decided to throw this in about Mass Save incentives, and I have a second slide about the IRA. And I think in addition to sharing the video, will you also be sharing the slides? I thought this might be useful for folks. Okay, great. So the Mass Save incentives have recently become more generous. They used to cover 75% off of approved measures up to $2,000, but that $2,000 limit has been lifted. Here are 3 common measures that are covered under that weatherization incentive. You'll probably be talking about this in upcoming presentation and upcoming sessions about the rebate for whole home heat pump replacements, which is now $10,000. And the heat loan financing has also recently become more generous. That's 0 interest financing. It's a 7-year term. It used to be the limit was $25,000 for everything, but they've recently increased that limit to $50,000 for heat pumps, and that's aligns with the state's electrification goals in order to meet our carbon reduction targets. So those incentives have become more generous. And as Colette started with at the beginning, there are currently in place new incentives through the IRA. The weatherization incentive has gotten more generous with the IRA. I believe there used to be a lifetime cap on that incentive, and now it's yearly. So you can use up to $1,200 every year, rather than I think it used to be a lifetime cap. I can't remember exactly what it was. That went into effect this year. There are also tax credits for heat pumps and heat pump water heaters, which I wish were more generous, because $2,000 doesn't get you very far with heat pumps. And of course, solar and batteries. The solar credit is retroactive to the beginning of last year, and the batteries started this year. And my understanding is that there will be additional incentives through the IRA coming online later in the year. So be on the lookout for that. Okay, now I want to move into a few case studies that show the steps that we have taken to improve and talk about 3 existing homes as in the course of, in most cases, there is sort of a renovation project as well. So this project was a 2017 multi-floor renovation to a house in Brookline, where we also did insulation upgrades and converted to heat pumps as part of the project. So focusing specifically on the energy measures of the project. Well, so the house was built in 1932. I think that's useful for context. Before we started, the basement was mostly uninsulated, but partly finished. The wall insulation was pretty mediocre. There are fiberglass bats in a lot of places, but there were some spotty places where didn't seem like the bays were fully filled, where there were spots you often see above and below windows or in corners where bays have been missed. So that's pretty standard for what we see in existing homes. This house the prior owner had insulated the underside of the roof with spray foam. So that was a measure that had already been done. They had a fairly old gas furnace and hot water heater and central air conditioning. So as part of the work that we did, the energy work that we did, in addition to the renovation, was so on the envelope side, we ended up insulating about the walls of about 30% of the floor area. There was limited opportunity to get into the walls of the spaces that we weren't renovating. And that's fairly common for renovation projects. If these walls had been uninsulated, We, in all likelihood, would have proposed insulating them from the inside. As you saw from the photo, previous photo, it's a brick house, which of course means you can't insulate from the outside. The only alternative then is to insulate. If the walls are uninsulated, you can make holes in each wall bay and dense pack them with cellulose, but that's not something you can really do when there's already some existing insulation. If there's existing cellulose, sometimes you can top it off. But in any event, there wasn't a lot of opportunity to insulate outside of the areas we were renovating, but we did the best we could in the spaces where we were taking off finishes. We were able to convert this house to heat pumps. We have a ducted system in the attic to serve the bedrooms, and ductless on the first floor of the house, a heat pump water heater and induction cooking. They already had an electric dryer. That's what we find when we mostly go into homes, that it's unusual to see gas dryers. So this was a full electrification, which was fantastic. And we were able to achieve fairly significant, what I would say are fairly significant energy and carbon savings with these measures, even though, we had sort of limited opportunity to treat the envelope. So close to 60% reduction in their site energy use. A lot of that too comes from the changing over to more efficient mechanicals, obviously, and then a close to 50% reduction in carbon emissions. All right, so the next project I'm going to show you is strictly a performance project. There was no renovation work as part of this project. We're just energy measures. This is a house in Newton. The house was built in 1938. It had fiberglass insulation at the attic floor, which was in, I would say, decent condition in about half the attic, or in good condition about half the attic, and sort of in mediocre condition in the older half of the attic. The walls of the house were completely uninsulated, and it's hard to see from this photo, but there's if to the right, you can just see a second story. That's an addition that was done over a first story over a one-car garage. I'm not sure exactly when that was done, but it turned out that the ceiling of that garage was also uninsulated. So the walls were uninsulated, the garage ceiling was uninsulated. I guess I should also add, although I don't have it here, that the basement was mostly uninsulated. They had gas heat and hot water and central air conditioning. So the work that we did was a fairly comprehensive treatment. So we insulated the underside of the roof in part because we did install a ducted heat pump in the attic to serve the bedrooms on the second floor. The client worked with Mass Save directly in order to install cellulose in the walls and the garage ceiling. This is a great case of where, as a shingle house, they could pop off shingles selectively in order to get into those wall cavities from the outside. And then through the Mass Save program, also did the rim or band joist air sealing and insulation of the basement. They elected not to insulate the basement walls. The mechanical upgrades, we moved to a combination of ducted and ductless heat pumps, again, ducted to serve the bedrooms on the second floor and ductless to serve the first floor spaces. That's a fairly common configuration that we find, that ductless heat pumps can do a good job in more open main living spaces where there either aren't doors or doors are left open. But in bedrooms, it can be a challenge to match the, well, let me put it this way. The loads, bedrooms tend to have their doors closed, right? So you can't have a unit, that's in a bedroom and expect it to condition an adjacent bedroom because the doors between those rooms are too often closed. And the loads of bedrooms are small enough that they're often smaller than the lowest capacity equipment that's available. And so you end up with slightly oversized equipment. And so we do sometimes elect to make that compromise and install slightly oversized equipment in bedrooms. There can be some downsides to that, but it's generally less expensive to go with ductless equipment. But in any event, now I'm getting off on, you're going to have a whole topic about heat pumps, so I won't get too much into that. We did a heat pump water heater, and then about 10.5 kW solar array. I noted in parentheses that it produces close to 84% of their energy use. Really, even more dramatic savings for a very comprehensive approach. We, again, except for the basement walls, we really treated the entire envelope of this building. 69% savings in energy use and 66% in operating emissions. And this homeowner likes to say that they opted up to, he and I have gone back and forth, they opted up to 100% renewable electricity, which he has argued means that we should drop his operating emissions to zero. I tend to think that that should be accorded to at the grid rather than at the house level, right? That those that you're contributing to the decarbonization of the grid rather than your house at that point. But in any event, that's a sort of meta point, again, beyond the beyond the scope of this talk. Okay, last, how am I doing on time here? Oh, it's only 7:45. We're good. Okay, so I have one more case study to share with you, and then we can have an extended Q&A, which is always fun if there are questions. So this is a project. Oh, I didn't say, I believe the last project we did, the whole house, the Newton whole house retrofit, that was in 2018. So this project, the one in Jamaica Plain, was done in 2019 and 2020, a first floor renovation as well as another comprehensive retrofit. This house seems like all the houses I chose tonight were built in the 1930s. Uninsulated basement, uninsulated walls. There was some fiberglass on the attic floor, a very old gas boiler and hot water heater. The hot water heater so old that our plumber was, he said, wow, I haven't seen a hot water heater this old in a long time. And window air conditioning unit. So this house was really a really good candidate for a comprehensive. Oops, I skipped ahead one slide. Go back. It also was overdue from the client's perspective for a renovation. This was a house that they had been in the family, had always been in the same family since it had been built, in fact, and the last time it was updated was, I'm going to say, at least 40 years ago, maybe. I mean, there had probably been some appliance change outs, but it had been a long time. So what really initially motivated these clients to get in touch with us was a desire to make the house more functional. And we were able to advocate for and incorporate a lot of energy improvements as part of that they actually didn't come to us asking for, which is, I'd say, probably more than half of our projects. People come to us for the energy. They come to us because of our focus on improving energy and reducing carbon emissions, and about half come for functionality and livability. And for the most part, as long as they're open to us suggesting and recommending energy upgrades, where we find that we're able to make a big improvement on that front as well. So the retrofit measures in this house, we, unlike in the previous project, we did insulate the walls of the entire basement. And one reason, I'm going to go back a slide, is we felt that was really important in this house. Is you can kind of see in the lower left picture, the back of the house here, that about a third to a half of their basement walls are actually above grade. And so those, if your basement is below grade, there's going to be less heat loss. Between the ground is warmer than the air. And so there's going to be less heat loss from the basement to the surrounding ground. But when those walls are above grade, it's going to be sort of the same amount of heat loss as for other above grade walls. And so we advocated for and were able to include insulating the entirety of the basement walls We dense packed cellulose in the wall cavities from the outside. And then we did this combination approach. I showed a picture of this earlier on of we insulated the underside of the roof again here as we were installing mechanical equipment in the attic, heat pumps to serve the bedrooms. And rather than do all spray foam, which is the way we used to do it, we've moved towards doing a combination of spray foam and cellulose. And the reason we're doing that, I'd say the primary motivator for doing that is an increased awareness and understanding of upfront or embodied carbon. And I don't know if this is something you all have talked about on any of your other presentations or will get into, but spray foam, foam in general is a higher embodied carbon product than cellulose. So there's a fair bit of carbon that is emitted in order to manufacture this product. Unlike cellulose, which has a recycled, plant-based product is very low embodied carbon. And there are actually ongoing conversations about whether it's appropriate to consider cellulose a carbon storing material. But again, that takes us into more complicated matters than we can get into tonight. Just suffice it to say, I think my point here is just to highlight that Byggmeister's approach to insulation has evolved over time as we have become more familiar with upfront carbon emissions. And we really recognizing that the time is short in order to achieve the reductions that we need in order to hold global warming to below, hopefully, 2 degrees Celsius. There's very little carbon that we can afford to emit upfront in order to save carbon down the road, or we need to save it in a short enough time frame that we don't sort of inadvertently or do things that sort of inadvertently put us over a tipping point. Not that, of course, whether we use, Byggmeister uses spray foam is going to make it that much difference. But if every contractor, every building project is using high emitting carbon, then we're in trouble, high embodied carbon materials. So we really need to think carefully about how much carbon we're spending to save carbon down the road, and what the time that, how long it's going to take to pay back those upfront carbon investments. Another ducted heat, mini split heat pump installation, heat pump water heater, induction cooking. I also, threw in some slides of the renovation, just so you could see this is as I said at the beginning, the sweet spot of our work is combining performance or energy upgrades with functionality and livability upgrades. And the dog is certainly happy. And one thing that makes us really happy is that clients have said to us a handful of times how much they didn't realize how much value they were going to get and how much more comfortable their house would be, because they were really initially in it for the functionality improvements. Again, fairly dramatic savings. I haven't included in this presentation any that are, all of the projects make us look really good. I can tell you for sure that we do projects where we try for all the projects, we try to save some amount of energy and some amount of carbon, but it doesn't usually look like this. It doesn't usually look like 80 and 70. I just picked some real outstanding projects to share with you. In fact, it's not common to see 20 or 30, even that's good. We try to leave the house better than it started. That's sort of our goal. And just because it's interesting, I threw in this monthly energy use graph. So it's really this sort of U shape, which is the darker bars, the before is what you commonly see for inefficient older homes. It's sort of high usage, very high usage in the cold winter months, lower usage in the shoulder seasons, and then sort of bottoming out in the winter. And what we were able to do is to, there's still a little bit of a curve, although it sort of ticks up a little in July and August, or it's actually, I should say, it was about the same in the summer months as it was before the project, just because I think they're using cooling more than they were with their window units. But in any event, it's just much more even, the energy use throughout the year than it was before. Okay, key messages. Decarbonization of your home begins, but it doesn't end with efficiency, with improving the building envelope with air sealing and insulation. I've made this second point a couple times. At least I've tried to during the presentation, that you don't need to super insulate your home in order to switch to heat pumps. Do the best that you reasonably can, and then electrify. And lastly, be opportunistic. Take advantage of renovations and other home improvements projects in order to improve the efficiency, reduce energy, and reduce carbon emissions. And I should add to that, that's sort of part of being opportunistic, is plan ahead. It's really hard to be opportunistic if you're caught in an emergency situation. So planning ahead allows you to be opportunistic with your upgrades. And I think that brings me to the end. So I will stop sharing and. All right.
That was great. A lot of things we don't think about. The invalidated carbon is one of them. So this was, very good, eye-opening. So we'll take questions from, we don't have anything in the chat. So if
Okay.
people want to just ask their questions, that would be great.
Uh-oh, did I put everyone to sleep?
Rachel, I do want to comment on the graph you just showed where you were looking at it, the old and present. We recently retrofitted our home and seeing phenomenal differences between energy usage from before and after. I'm attempting to keep track of how much money we're saving on it, and give me another year and we'll have some dollar figures, but the savings are there.
Paulette, I'd love to hear, I see Andrew has a hand up, but I'd love to hear what you did to your house.
Oh, we'll have to take time to do that.
Okay, right.
Andrew?
Thank you, Rachel, very much. It was an excellent presentation, and
Welcome.
I think a really, really good primer on like how to, for novices like me, how to start on tackling the whole problem of getting closer to net zero. And I know we're going to have a special session on heat pumps, but I wanted to get your thoughts on a house that has central air conditioning with ducts to all of the spaces in the house. When you're working with clients, do you recommend that they have a heat pump that ties into the ductwork so that you're not in another element? I know you had some second floor ducted work and then some first floor ductless units.
It's a really great question, Andrew. And we have found that depending on the condition of the ductwork, that we can sometimes reuse that ductwork, but it depends. And so it's definitely something to look at. If we can reuse ductwork, we will, or at least reuse part of it.
Are there factors that influence what is good ductwork versus something that isn't reusable?
I mean, some of it depends on just the quality of the installation. Some of it depends on the air will flow, sort of the pressures for heat pumps and airflows are going to be a little bit different than for your central air conditioning system or for a furnace. And so we need to look at that. But I would say the other factor, you did say you have ductwork to the whole house. If you have a 2-story house, we typically don't want to distribute from, let's say, a unit in the attic all the way to the first floor. Like if you have what we often find in homes is there'll be an air handler, central air conditioning air handler in the attic with ductwork that is then serving both the second floor and the first floor. and it's hard to achieve the, you may find that now, if that's your situation, but so some of it depends on the configuration of the ductwork. Some of it depends on how well it's installed, what kind of ductwork, but it's definitely worth looking at. I wouldn't assume you need to throw it out.
Okay, great. Thank you.
Lisa?
Hi, Rachel. Thank you. That was
You're welcome.
yeah. My sister's house is a stucco house, and it has 0 wall insulation. And it's a fieldstone basement with a 2nd floor and no attic.
Okay. So do you know, is the stucco, are the walls wood framed?
I don't know.
So with masonry, like structural masonry walls can be very often impossible to insulate,
Right.
if that's your situation. The fieldstone foundation, that it sounds like what you're talking about is perhaps a structural masonry construction, which is going to be really challenging.
Yeah.
Yeah.
Yeah. Any suggestions at all?
Not off that we have found it very challenging to, I don't even know if we've been able to insulate those walls. There's just, I don't off the top of my head, unfortunately.
Yeah. Yeah, this is the answer I thought I was going to get.
Sorry.
I mean, because it's a tough situation. It just is.
Yeah. I wonder, you said there's a 2nd floor and no attic. There's nothing. Is it a flat roof?
No, there are side center rooms and then side crawl spaces, I guess.
Oh, I see. Well, anyway, I'm wondering if there may be opportunities at the roof level that I'm not fully understanding the configuration, but sometimes there can be like we encounter sort of a finished attic space, and those sometimes you can get into sort of, there's a flat attic above there, you can insulate up there, depending if there's finished slopes, sometimes you can insulate down those slopes and then get into the knee wall areas as well. But I'm not sure if that applies to your situation.
Yeah, knee wall, yeah, and I don't know. I mean, there's a very narrow, flat roof. They're angled.
I'm sorry. I feel like maybe you could feel free to email me separately. Okay.
I was going to add, Lisa, is your sister in or near Lincoln?
No.
No, okay. If it was your house, I would say call us and we'll come out with a FLIR camera so you understand where your heat loss is.
Well, okay. Yeah, we're not in Lincoln. I used to live in Lincoln and got hooked up with y'all. But okay,
Thanks for your question. Sorry not to have a more satisfying or answer.
Yeah, thanks.
Susan? You're on mute, Susan.
You can't read my lips.
No.
I have a 200-year-old house, and I'm sort of embarrassed to say that I have oil heat and an oil water heater. And what really annoys me in the summer is to hear that darn oil burner go on just to get hot water. I'm not sure I'm ready to go to a heat pump yet. Is it an easy switch to an electric water heater?
Yes, that's a short answer. Yes,
Okay.
I mean our water heaters of choice are either a heat pump water heater or an electric resistance water heater. Heat pump water heaters are more efficient than electric resistance, but if you think about sort of your overall energy use, you're water heating energy use is a small-ish
Yes.
slice of that pie. And if you're not a heavy water user, like if you're not a high occupancy household, it would take a fair amount of time to sort of recoup the cost of the efficiency gains of a heat pump water heater. So we often put electric resistance water heaters in lower occupancy homes. And then we also do them when people, there are some other downsides or compromises with heat pump water heaters, which don't work for every home. They do make the space cooler where they're installed, because they, rather than a heat pump for heating and cooling, which exchanges the heating with outside, the heat pump water heater is heating water by drawing in heat from wherever the space that it's located in order to heat the water. So it can make the space cooler, and they're a little bit noisy. So if you don't have a bit, they're great, they're good, they can be good for basements, but if you have a 200-year-old house, so I'm sure you have a basement.
It's in the basement.
In any event, it's not a solution for every home, and an electric resistance water heater sounds like it could be a good solution for you.
And who would I call to get more information on that?
Plumber.
Just a plumber? Okay, thank you.
Roy?
Yes, thanks. Very interesting presentation, like your business model of combining the performance upgrades with the functionality improvements. My question is on ventilation in rooms that are served by ductless heat pumps. If you've air sealed and you don't have ventilation in a room, how can you add that? Is there like a through wall single room ERV that can fit in, old-fashioned walls with a 2x4 stud wall? I've seen some through-wall ERVs, but they're designed for passive houses with foot-thick walls. And just wonder what's suitable for the kind of these 1930s houses that you tend to do a lot of.
Yeah, it's a really good question, Roy. So just to zoom out for a second.
It's hot. We gotta get moving.
I think is somebody unmuted? Okay, I think maybe that was somebody in Roy's house. So to zoom out for a second, Roy, we rarely get homes tight enough that we would be required by code to add continuous ventilation. That doesn't mean it's not a good idea. I'm just saying that the type of work that we're doing and the air tightness or the air exchange rates that we're getting to are occasionally low enough that we would be required to add whole house ventilation, but not always. We oftentimes include them in our projects. We propose them particularly for bedrooms. So we'll say, let's not, this goes back to my message of don't let perfect be the enemy of good. So putting in a whole house ventilation system, putting in even ventilation just for bedrooms can be very expensive. But I would say it often gets cut from our projects because it's a not insignificant expense to try to get ventilation into every bedroom. A sort of compromise approach is to install, and again, it's a compromise, an exhaust only vent. So in your bathroom, to install an exhaust vent that can be set to run either continuously at a very low speed or to kick on for a number of minutes each hour. And then what you're doing then is you're relying on the remaining flaws in your air barrier in order to bring in fresh air. That's then, so you're cycling, getting fresh air exchange in that way, which again is a compromise. But it's more often than not what we end up doing. Again, not because we think it's best practice, but because we find that we're having trouble selling ERVs. I don't know how else it sounds sort of crude, but we're having trouble making the case that they're really necessary. Oh, now we want to hear what you're saying.
Roy, we can't hear you. Can't hear you. Maybe you can type it into the chat. Okay. Michael Moody asks, how do you do the combination of cellulose and spray foam in the attic ceilings?
Okay, so the sequence is, well, I'm not, we build down the rafters because we need to get a thicker level of insulation. We then install install spray foam in order to achieve, we install 3 inches, which is what we need in our climate by code for condensation controlled, because closed cell spray foam is a vapor closed product. And so vapor diffusion, in order to keep the underside of the roof sheathing from getting wet from vapor diffusion. So we install 3 inches of closed cell foam. And then we, I think what I was showing in the photos was a membrane. The product that we were using, I think, was Intello, but a membrane that we attach to the bottom of the roof rafters, and then we dense pack the cellulose behind that. It's a more complicated approach, and it costs more than just doing spray foam.
Let's see. Let's finish Roy's. He says, for those customers who do believe in the value of ERV, what device do you recommend for the bedroom that has 2x4 stud walls?
So we haven't done a lot of we haven't done the through wall that you're talking about. We may have done like a Luno system once or twice. What we would typically propose is a ducted system that would have, so I can't speak to what would recommend as a unit that would just be for a single bedroom. I haven't done that.
We have a question from Pallavi. Wondering if you've retrofitted condos in multifamily buildings, how do the energy use reductions get qualified, since we have a central boiler and no central air conditioning?
Wow, so a central boiler that's serving all 3 of the units in multiple units in a, so it's 1 meter for the whole building?
Yes. Yes, 1 meter for the whole building.
I do not know the answer to that. I've never worked on a building like that before with a central plant like that. Is this how large is this multifamily?
We have about 2 buildings combined, 16 units.
16 units. And is your condo association interested in exploring?
Yeah, I am on the condo association, and I was, before I even suggested to others in the building, I wanted to at least know if it's feasible or has been done anywhere.
I think you would want to work with a firm, as a consulting firm, that works more with multifamily than a firm like Byggmeister, which really works on the scale of single family and small multifamily. So sort of like single family scale homes that have been like 2-family homes, or sometimes a triple decker, for example. But I think off the top of my head, New Ecology, I don't know if what you're proposing, if your building is too small for them, but I might consider, I think you're going to need a consultant that specializes in multifamily to help with something like this.
That's helpful. Thank you.
You're welcome.
Ed?
Hi, I had two questions, mostly dealing with the other side of what of insulation. I'm sorry, air sealing is the thing that I'm interested in. Sorry, it takes me a little time to get going here. So air sealing, I think you answered my questions that you use, foam and you use a membrane. And I'm wondering whether that's covered by Mass Save and whether the average insulation contractor does that sort of thing of giving a good air sealing result.
I'm not sure how to answer that question because yes, Mass Save should cover some air sealing measures. Whether or not your average insulation contractor is going to do a good job with that is another question entirely. I think there is differing level of quality with weatherization contractors. I have certainly run into that, particularly, I shouldn't say particularly, but in the context of speaking with our clients who've worked with Mass Save, and I've seen a range of sort of very diligent, contractors that chase down every last air leak that they reasonably can and still get, paid by the program, and really do a good job with quality control to contractors who are, I guess, maybe, I don't know if less conscientious is the right word, or they're just moving more quickly. So I do think that it does vary.
And so I think that's a problem we could all use you, actually. We can.
And we have a secret weapon. We work with as a sort of consultant subcontractor, a gentleman who comes in and quality controls most of our insulation jobs. That's what because he'll crawl into the smallest, dirtiest spaces. He'll prepare them right for insulation, and then he'll come back after them to make sure that they're done right. But he's one of a kind.
So I'm just thinking for Belinda's benefit of who she recommends when people talk with her, and how you make sure you have reasonable. I'm very happy that you addressed the condensation on the inside.
Yeah.
Belinda,
do you have firms that you feel like you have vetted either from talking to other people or?
No, we really need to come up with a list. The only person I know is you.
Oh my gosh. Well, maybe we can talk about that offline, and I can share some of the firms that we work with and just what we've seen, because I often, we have our insulation contractors who we work with, and then we do our own quality control, but just sort of what I've seen from going into other houses that have been done by Mass Save and where I feel like they've done a good job.
That would be.
I don't really want to say, I don't think I want to put all that information in this recorded video.
But yes, it would be very helpful to have a list of people that are,
with the caveat of this is just, this is just,
we just, people need a place to start.
Yeah.
So that would be great.
It's like anything, the referrals really help.
You've answered everybody's questions, I think.
Well, that's fantastic.
Yes.
I think
Okay.
we should wind up the session tonight. We've gone over time. Rachel, really, really appreciate your presentation and answering all of the questions and showing up with such a great smile. It was a wonderful evening and full of information. I want to remind everybody that we're doing a presentation next week on Windows. It'll be at noon on Tuesday next week. And I hope that many of you can attend, tell your friends about it, because this is going to be, again, another very, very good presentation. Thank you, everybody.
Thank you.
Thank you for having me. I really enjoyed myself. It was fun.
Thank you.